This is a slide deck presentation of IoT big data applications in Mercedes-Benz. As we look at the history of IoT applications in the automotive industry, we see three important years. 1984, when compact discs started the revolution of infotainment system in cars. 1994, when dashboard infotainments were developed, and 1995, when GPS system was first used in cars for navigation. From 2000 and onwards, IoT was much more developed, and after the integration of USB and Bluetooth technology, it is estimated that by 2021, there will be 94 million cars connected with IoT devices via Wi-Fi and other software applications. Now, we look at some of the IoT trends, and we find that starting from 2014, the number of patents in IoTs in the car industry exploded up until 2020. And recent data shows that in the Q2 of 2021, the number of business deals in IoT, like mergers and acquisitions, venture financing, asset transactions, crossed over $25 billion, only in the automotive industry alone. Because of this, the numbers of jobs in IoT have also increased, as we can see that Mercedes-Benz is ranked 4th among the most hires for IoT jobs in this industry. Looking at the IoT applications in Mercedes-Benz, the new digital ecosystem called Mercedes-Benz Operations 360 comprises of software applications which are connected via shared interfaces to digitize car production in Industry 4.0 revolution. It is going to increase the flexibility in operations and reduce the carbon footprints. Mercedes-Benz enables the MO360 enables the Mercedes-Benz to make use of this cutting-edge big data analytics and also to implement artificial intelligence methods in production. It delivers slightly optimized KPI-based production controls. For example, it can make individual need-based information and work instructions available to each employees in real-time settings. Now, looking at the IoT big data in business optimization, it is expected that between 2020 and 2024, the number of connectivity units in cars is likely to increase by 67%. One such application of IoT can be predictive maintenance technology, which through combining big data, cloud computing, the car can evaluate the risk factors of malfunction and can conduct diagnostics and prognosis by itself. If we look at the picture on the right, we can firstly see that there is there's an inbuilt in-vehicle monitoring system that is going to collect data from the different sensors attached to the starters, fuel pumps, and battery, etc. And then this data is going to be transmitted to a cloud server, and the cloud server is going to predict potential maintenance issues, and then it is going to provide recommendations to the drivers via a connected device. The Mercedes-Benz EQS model, which is set to release in 2020, is going to be the first electric model of Mercedes-Benz, which will contain the full set of predictive maintenance technology. Implementation of this technology will save both time and cost of car repairment, increase the life values of cars through diagnosis before parts failure, and increase the customer trust, safety, and satisfaction in the company. Back to our optimization model from the second assignment. Looking back at this optimization model that I have done, the objective was to maximize profit through production optimizations of various car models. However, this model had some drawbacks. For example, it relied upon historical data to predict how many units would be sold in the next year and equally distributed the production amounts among all the car plants. It did not consider seasonal trends of car sales and inventory management, although the model produced an optimal production unit of 2.75 million units because it couldn't produce 4 million units due to certain constraints, such as there can be no fractional units in the model, etc. Given the simplicity of the model assumptions, Mercedes-Benz could have produced 4 million units and would have made a lot of profit if they had sold those units. These drawbacks mainly stemmed from not considering certain factors such as production capacity, inventory, seasonal demands in my optimization model. So how can big data improve my optimization model? Big data can improve the efficiency of my model by considering all those variables. Like, for example, if we look at the picture on the left-hand side, we see that all the plants are producing the same units of cars and not taking into account of seasonality of demand. And thus we have an inventory, thus we have a high number of inventory, which becomes a depreciated asset if unsold. Secondly, maintenance of these inventories increase operational cost, which eats from our profits. So thus, on the right-hand side, is in the figure we can show. I have shown how big data and data analytics can improve our optimization model by updating us about real-time inventory management, and can make recommendations to either halt, continue, or increase productions to meet our monthly demands, as it does not take into consideration a particular production unit at the beginning of the year. These variables can be changed at times to constantly update and improve our optimization model. Thank you so much for the presentation.